Alright guys, welcome back to the channel. Welcome back to Math Plastic. In today's video, I'm kind of just going to introduce a new series of videos. I'm going to call this series Calculus 2.0. Essentially, this will just be a higher version of calculus. It won't be like the normal one that we do in SHS. And we are going to look at certain concepts, certain basic concepts, or kind of try and understand it or associate them with certain basic concepts. So it will be a series of tutorial videos, and this is the first one, of course. This particular one will be in maybe just an introduction to everything that will be needed for the rest of the series. So in this particular video, first I'm going to be looking at multivariable functions, essentially functions with multiple variables. And after looking at that, we're going to be looking at kind of a way of visualizing multivariable functions. And then after looking at that, we'd also look at kind of like maybe what calculus is in general. Then finally, we'll be looking at why we should use multivariable functions. So why, let me clean that. Why multivariable functions. So I hope this series will help us understand calculus, basically a higher version of calculus, like I said earlier. And without wasting much time, let's just get into that. Now, before we start this series, there's going to be a basic assumption that you already know what functions are. You already know what functions are, and you know how functions work. So I made a video on it first where I said function is a boss. I'll link that video in the description so that you could go and look at that and try and have an understanding of functions. Of course, that video is not like covering everything under functions, but it should give you a basic knowledge of how functions work. With that being said, let's look at multivariate functions. So multivariate functions are just those functions that take more than one input variable. So most likely the functions that you already know are single variable functions. So let's say they take only one input variable. Let's say a function f defined on x to be equal to 2x. This function, let me change the color. This function f takes only one input variable x and then produces an output by evaluating this 2x. So it kind of multiplies the input that it takes by 2, and then this evaluation results in the output. That's a single variable function. Now a multivariable function would take more than one input. So let's say a function capital F defined on, let's say, x and y. In this case, the x over here, it's one input, and a y2 is another input. So this function f takes more than one input. Let's say this function f defined on x and y is equal to, let's say, 2x plus y. So obviously this function takes x, multiplies it by 2, and adds it to the second input that it takes. So if I evaluate this function at, let's say, a point 2, 1, where 2 stands for x, the 1 stands for y. So f of 2, 1 would be equal to 2 multiplied by 2 plus 1, because the 2 here is the 2 here, and the 1 here is the 1 here. Obviously, that's the x and the y values respectively. So this would be equal to 4 plus 1, and this should be equal to 5. So the value that the function gives out at the point 2, 1 is 5. It's no different from the normal functions you know. It's no different from the single variable functions you know. It's just that this one, the number of variables are extended to 2, or maybe more than that. It could be more than that. It could be 3, it could be 4, it could be 5, it could be an infinite number of variables. Now let's look at a way of visualizing these multivariate functions. For a single variable function, let's assume one. Let's say f of x to be equal to 2x, like I've always been using. To visualize this function, you could maybe use a graph, a two-dimensional graph, the xy plane. Let's say this is our y and this is our x. That's assuming that y is equal to the functional value at certain points of x. So if I take this x to be, let's say this is 1, 2, 3, and 4, and let's say this is also 1, 2, 3, and 4. The functional value at 1 would correspond to, f of 1 would be equal to 2 times of 1, which would be equal to 2. So the functional value at 1 is 2. So if you substitute 1 into this function, you would get 2. So you can have a point 1, 2. If you substitute a 2 into this function, f of 2, you would get 2 times 2, which would be equal to 4. So a 2 would give somewhere around here, a 3 would give a 6 somewhere around here, and you would most likely have a straight line passing through here. This could be used to visualize this kind of graph. But if you consider multivariate functions, because they are defined on more than one variable, a two-dimensional axis cannot be used to plot their graph. For example, let's consider a function g defined on a and b. Now, when you evaluate this, already you have two input values, a and input b. If you evaluate this, you will get a third value, let's say a c. So you need 3 axes to plot this. You need a 3-dimensional graph to plot this. You kind of draw a 3-dimensional graph on a 2-dimensional surface. Let's say we have something like this and like this. So it's kind of, you have to look at it in that kind of 3-dimensional way. Even though it's on a 2-dimensional surface, kind of have to imagine it in a 3-dimensional way. So let's say this axis is axis A, this is axis B, and this is axis C. So obviously to take a certain input over here and a certain input out here. And to make it easier, let's give it something to think about, to use to draw the graph. So let's say this g of AB is equal to A plus B. So if I have, let's say, A to be 1 and B to be 1, that point to be somewhere around here. But we'd have to extend that one to, like, let's say something high. We have to give it the C value to the value evaluated. So the function of the value of the function at 1, 1 would be equal to what? 1 plus 1, which is equal to 2. So you have to plot this third value, which is a C, against this one and then this one. So you'd have a 1, 1 and a third value to plot on this axis, which, let's say, if this part is 1 and this part is 2, you might be having something around here, and then this kind of like extends up to the 2. So you have to kind of like visualize it in that kind of 3-dimensional view. This introductory video will not maybe give you all the information that you need to actually understand this, but it's supposed to help you kind of get how you're supposed to visualize 3D functions, or functions that should be plotted in a 3-dimensional space. Now that we've kind of understood how to visualize this kind of multivariable functions, we can now look at why we should actually maybe know about multivariable functions. So we now think about why are we learning multivariable functions? Why can't we just use single variable functions? Why are we learning multiple variable functions? The reason is simple. Functions are used to model things, like model natural phenomenon, model the kind of relationship between certain quantities in nature. But the fact is that naturally some features are not dependent on only one variable, only one other quantity. Let's say the population. The population of a country, let's say Ghana, at any time, is not dependent on only one thing. It could be dependent on the availability of food, the death rate, the birth rate, and other factors. Let's say the number of jobs available, the number of females, and a lot of that. So the population would have to be a function of all of this. The population would have to be a function of all of that. And for that reason, we can't just say that it's dependent on only one thing. but rather a number of things. So the population has to be like a function of the food, the death rate, the birth rate, and a whole lot of others. So we can't just say that the population of Ghana depends on only one thing. And for that reason, and yeah, it's not only the population, it could be other phenomenon, it could be other quantities and a whole lot of other stuff. It's not only this, but most of the quantities that exist in nature, their values depend on more than one other quantity. And as such, the multiple variable functions or multivariable functions help us to model this kind of relationship between certain quantities. And that is the major reason why we are doing multiple variable functions or multivariable functions. And now finally, to help us conclude this introductory video, let's look at what am I writing? Let's look at what calculus is. So what is calculus? That's a big question. It's a very good question to ask. Now, Wikipedia defines calculus as the mathematical study of continuous change. Calculus has to do with changes, and yeah, these changes are kind of modeled with calculus. Calculus helps us model these changes and kind of try to understand changes that occur in certain quantities in nature. Now, calculus itself, when you take calculus, it has two major fields under it. Let's say, okay, well, I'm not saying that's how it is. It has two major fields, the integral calculus and the differential calculus. You might have heard these names before. Anyway, let's take the differential calculus. Differential calculus has to do with finding the rate at which certain changes occur. So we said that calculus has to do with the study of changes. So when you are kind of studying the rate at which these changes occur with respect to other quantities and other stuff, then you are looking at the differential calculus. That's what it does. That's what it's about. On the other hand, integral calculus has to do with kind of understanding and summing up quantities. So it's kind of finding the totals of certain quantities. This has to do with summation in general. This can have to do with summing. Yeah. Now, these are the two major fields. Obviously, the integral calculus will do with integration, and this will do with integration, and this right here has to do with differentiation. Yeah, we will look more into that during the course of the video and during the course of the series. I mean, this is just an introductory video. And with that being said, I thank you all for watching this video. This video is not supposed to be much of a tutorial, but it's just supposed to be an introductory video to the new series that is coming up, Calculus 2.0. I hope you enjoy it, and yeah, thanks for watching. If you enjoyed the video, please leave a like behind and subscribe to the channel if you're interested in this series. Thank you for watching, and I'll see you in the next video. Peace.